Alright, hey guys. Let's see, this would be Wednesday. A little review from yesterday because this is some really important stuff that we need. Now, again, I told you yesterday, um, you could easily plug this in your calculator. I understand. But most of what you do in trig is exact value, so we don't want some decimal approximation. So we're going to use our reference angles and our special right triangles to evaluate. Well, if you have a 30-degree angle, this is 90, so this has to be 60. So opposite of 30, has to be 1. Opposite of 60 is square root of 3, and this has to be 2. Sorry, guys. And so sine is opposite 1 over hypotenuse, 2. Easy enough, 1/2. Tangent, and that's some axis. 120, so you go over 90, you go over again, so 30, that's your 120. Now again, now we're going to use our reference angle to evaluate. Okay, and so we have to do 180 minus 120. This is a 60-degree angle, so we draw our triangle. This has to be 90, this has to be 30. Opposite of 30 is 1. Now remember, we go over 1 to the left, so it's got to be -1. You go up on the y-axis, so that's positive, but this would be square root of 3. And the r, or the hypotenuse, is always going to be 2. Positive. It's always going to be positive, not always going to be 2, sorry. So tangent is opposite, which is square root of 3, over adjacent, which is -1. So it equals negative square root of 3. Which makes sense because all students in quadrant 2, sine and cosecant are going to be positive, but all the others will be negative. So it makes sense that tangent's negative in quadrant 2. Okay, so moving on, just overall, this is a little circle for all of them, and so this labels it as cosine and sine. And so right here, for instance, you have a 30-degree angle, which cosine at 30 would be square root of 3 over 2. Sine at 30, 1/2. Okay, and so at 45, you got your cosine, your sine. At 60, you got your cosine, sine, so on and so forth. So these you could use to check your answers in anything you're doing. You could easily find this online. Just type in trig unit circle ratios, something like that, and it should shoot out something similar to this. So it wouldn't be a bad thing to print off or even write down. Normally I have a worksheet for you guys to completely fill out, but I don't want to add to the stress of this e-learning, okay? And as long as you know how to find these, it's not necessarily about memorizing. I honestly haven't memorized them, but as long as you can find them using, these triangles. Oh, no, stop. As long as you can find them using these triangles and the ideas to reference angles, then you're sitting really good, okay? And that's what we want. And so again, anywhere on your circle, let's see if I can even draw a circle. Oh boy, looks like Igor. You have to use the x, y's, and then the fact that r is always 1 to evaluate. So sine at 90, opposite, which would be y, 1 over 1 is 1. So you got to use these ideas. So again, if you don't have this written down from yesterday, please do so. I'm going to try to make this video a little shorter because I know yesterday was longer. So we're going to evaluate trig functions using trig identities, and then we're going to find the area of triangles for non-right triangles, okay? So I think you guys are maybe lucky. I'm skipping through the proofs. I don't know if they're necessarily beneficial. If you're interested in the proofs, I could definitely make a video for you showing you. But we're just going to get to that, the what's, not the hows, okay? So Pythagorean identities, this was my proof page. So these are a lot of Pythagorean identities and reciprocal identities. These we already talked about here. We haven't necessarily talked about this. So tangent of theta is the same as sine over cosine of that, okay? And then cotangent, the reciprocal, cosine over sine. We haven't necessarily talked about that, but that's another reciprocal identity that we use, because I could prove that one pretty easily. Sine equals y over r, right? Cosine equals x over r. So tangent would be sine divided by cosine. So it'd be y over r divided by x over r. Well, dividing by a fraction is the same as multiplying by reciprocal. So it'd be the same as y over r times r over x. Well, guess what? R's cancel. You get y over x, which is tangent. Okay, so that's pretty easy to prove. And so more things, we'll be using some of these today. Sine squared of an angle plus cosine squared of that angle always equals 1. That can be proven from the Pythagorean theorem. That's what I skipped on the last slide. Also, tangent squared of theta plus 1 equals secant squared of theta. And finally, 1 plus cotangent squared of theta equals cosecant squared of theta. Okay. Now, important thing to note is basically, remember, tangent of theta is just a value, it's just a number. And so we write the squared in front before the angle, but what it really means is tangent of theta squared. We write it like this because if you put it over here without parentheses, it almost looks like you have to square the angle first before you plug it in, okay? And so if you write tangent squared of theta, it basically just means tangent of theta all squared, so that value squared, but we write it with the exponent next to the n, okay? And so these values here, let me clean it up a little bit for you guys. These you should probably have written down, because I'm going to guess that you're not going to memorize these. Again, I'm still trying to think about what our test looks like. This is not, I don't think it's going to be pretty, but normally students ask, well, do we have to memorize all of these or will it be on a test? I usually give you guys cheat sheets. So whatever type of test we'll do, there will be a this will be involved, so you won't have to memorize. Okay. Moving on. So there's two ways we can do it. We can use trig identities to find all the values of the trig functions, or we can just use some common sense and knowledge. And so what it means is find the values of all the trig functions. They want us to find cosine of this angle, sine of this angle, yada yada. They don't tell us the angle, but they do tell us the ratio. Okay? And so let's hold that thought for a second, actually. Let's use trig, one of our identities, to solve this. First off, let's use sine squared of theta plus cosine squared of theta all equals 1. Well, sine of theta equals this. So we could plug in negative 5 over 13 squared plus cosine squared of theta equals 1. Well, if you square this, you get 25 over, is it 169, I believe, plus cosine squared of theta equals 1. So I'm going to subtract this over, this value over. I'm not sure what just happened. So you have cosine squared of theta equals 1 minus 25 over 169. Now again, when you square this, a negative times negative is positive, so it becomes positive when we squared it. And then we need a common denominator. So we need 1 as a fraction over 169. So that equals 169 over 169 minus 25 over 169. So we do that, you get cosine squared of theta equals, is that 144 over 169, square root, so you get cosine of theta equals square root. Now if you square root a fraction, remember that you could write it all in one fraction, or it's the same as taking the square root of top and the square root of bottom. So you get 12 over 13. So that's cosine of theta. So we know sine of theta. Let's write cosine of theta equals, we said 12 over 13, which means what? Let's write down, we know our, first off, they tell us the quadrant. So if I draw a little picture, that's in quadrant 4, right? So our y, it makes sense that it's going to be -5. Our r is going to be 13. What's our x? Well, cosine is x over r, or adjacent over hypotenuse. So this is 12, which makes sense as positive. So we can easily find out tangent, cotangent, secant, and cosecant now, right? Tangent would be -5 over 12. Cotangent, the reciprocal of that, 12 over -5. Secant, reciprocal of cosine, should be 13 over 12. And cosecant, the reciprocal of sine, would be -13 over 5. So again, this is quadrant 4. So the only ones that should be positive, all students take calculus, is cosine and secant, which is true. Because sine's negative, tangent's negative, cotangent's negative, and cosecant's negative, okay? And so that's one way to do it. Option 2. So if you have not already, copy this down because I'm about to erase it. So let's pretend we don't know this guy right here. I should not have erased all the cosine, tangent, whatever. So we need to find this side length, right? And so we can easily do Pythagorean theorem, which r squared would be 13 squared equals, let's call this x. So x squared plus y squared, which would be -5 squared. Well, you get 169 equals x squared plus 25. Solve for x, subtract 25 over. X squared equals 144. Square root x equals 12. Oh look, so this right here, this guy right here, is 12. So then you can find your sine, cosine, tangent, right? Cosine, I'll just do cosine and tangent again. Cosine of this angle right here is adjacent over hypotenuse. Tangent is opposite over adjacent, so -5 over 12, so on and so forth. So I'm not really particular which way you can do it. This way that I just demonstrated makes more sense to me. It's a lot more easy. And all you have to remember is the Pythagorean theorem, really, which I assume you guys will remember. If not, look it up. X squared plus y squared equals r squared. Okay, so I don't care which method you use, but you just have to find the values of all the trig functions. So it's important to note we don't know the angle, so we can't use kind of the idea of reference angles. They just tell us side lengths, so we have to find the missing one and then solve the rest of the, or find the rest of the ratios. Okay, so moving on, let's do that again. Now, again, you could use the idea sine squared of theta plus cosine squared of theta equals 1 and do all that. I'm not going to do that. I'm just going to do our second method, if that's alright with you guys. So I'm going to draw our picture. We know we're in quadrant 1, so I'm going to draw my triangle. They tell us this side length, x is 1, our hypotenuse is 2. Okay. Well, you could easily find this using Pythagorean theorem. You have 1 squared plus y squared, calling this y, which makes sense, it's the height, equals 2 squared. So you get 1 plus y squared equals 4. Subtract 1 over. Y squared equals 3. Take square root. Y equals square root of 3. So this guy right here is the square root of 3. Now these are all going to be positive because we're in quadrant 1. So we go over to the right. So x is positive. We go up. So y is positive. And r is always positive. So sine, tangent, cosecant, secant, cotangent. I know, beautiful. Sine of this angle would be square root of 3, opposite, not 7, 3, over 2. Tangent, opposite over adjacent, square root of 3. Cosecant, reciprocal of sine. That equals 2 over square root of 3. Again, you have to rationalize, so 2 square root of 3 all over 3. Secant, opposite of cosine, so reciprocal of 2 over 1 is just 2. And cotangent, the reciprocal of square root of 3 would be 1 over square root of 3, which rationalize, you get square root of 3 over 3. Okay, so easy enough. Just draw your picture. You have to find your missing side length using Pythagorean identity, or Pythagorean theorem, sorry. So I think that's easy enough and painless. Now, I was going to prove this to you guys, but I don't think we're going to. Okay, so this is what's going to happen. We have two formulas for the acute angle, or if we have an acute triangle, which means it's not obtuse, right? Less than 90. The formula is going to be A equals 1/2 A times B sine of theta. So basically, your A and your B are just two side lengths, and theta is the side length, or is the angle in between them, okay? So this right here is just a number. You can type that in your calculator because we'll be doing decimal approximations for area. Okay. So really, it's just 1/2 times the two side lengths, and then sine of the included angle. So you have to choose two side lengths with the angle included. Okay, so this has to be the angle included. It can't just be any angle. So this theta couldn't be this one, unless you have this. Unless you're using, I guess it'd be this side length. So ignore the h. That was used to prove it. We're not even gonna prove it. So you're just gonna use this formula here. Okay. So don't even get confused. Again, that will probably show up on tests. Only thing different with obtuse angles or obtuse triangles. So we have, again, ignore this h. Pretend we don't even have it. We just have this, and we have this angle. Let's call it theta. And so it's A, the area, equals 1/2 times A times B. Oh, the only thing different is it's times sine of 180 minus theta. Okay. So you would, I don't know, let's say this is 120. So you do 180 minus 120, which would be 60. So it would be sine of 60 in here, okay? So that's the only thing different with the area of an obtuse triangle, is you have to do 180 minus that value, okay? Any questions on that? I don't know why I asked that. Sorry. Habit, I suppose. So write those down. Make sure you have those. And let's do a couple examples. So right off the bat, find the area of a triangle. Hopefully it's obvious this is obtuse. It's bigger than 90. And so the area equals 1/2 times the two side lengths, so 10 times 3, then times sine of, now remember, if it's obtuse, you have to do 180 minus our angle, which is 120. So area equals 1/2 times 10 times 3 times sine of 60. So again, I mean, this is just plugging into your calculator. you have 1/2 times 10, which is 5, times 3 is 30, so it equals, what did I say? Times 3 is 15, times sine of 60. And that's and if you plug that in, so 15 times sine of 60. Now again, if you're plugging in a degree into your calculator, you have to be in degree mode. So 15 times sine of 60 gets you about 13 units squared. So that's about the area of that triangle, okay? So easy enough, right? So the only thing different if this was acute would be you want to do 180 minus that value. You would just do this angle, okay? So a times 1/2 a times b times sine of the included angle. If it's obtuse, subtract it from 180. I think that's going to be it for the lesson. Make sure we turn in yesterday's homework. Today is due by 4 p.m. This again is our homework assignment. Now keep in mind, if I change the homework assignment on that HyperDoc, go with what's on the HyperDoc, okay? Because maybe I realize there's something that I intentionally skipped, but then I need to adjust that on the homework. So always go off of what's on the HyperDoc, okay? So again, make sure you ask questions, anything. Now, we're doing some calculations on the calculator here. So if you have questions on how to do that, there's online calculators. I think your phone might have most of what you need. But other than that, I will see you guys tomorrow. We have one final lesson for this chapter. Okay?